Right, grade 11s, on to question 4. Question 4 says, consider the functions f of x, which looks like an exponential, and g of x, which is a straight line. On the same set of axes, sketch the graphs of f and g, labeling all intercepts with the axes and with asymptotes. Now, once we are drawing two graphs on the same set of axes, we need to be a little bit more careful about scale. Okay, well, let's do the working out for this exponential. First of all, to look at my shape, I can see that my base is 2, which means it's an increasing exponential. It's got multiplied by 3, but as long as that's not a negative, it hasn't been reflected, and so I don't really care. But hang on one moment. This graph has moved 6 units down. So my asymptote will be at y is equal to minus 6, and my graph will look something like that. Now, it might go through the origin, or I might have a separate x and y intercept. I'm not too sure yet. But basically, that's what it's going to look like. Okay, let's look at our straight line. Immediately, I can tell from this equation that it's going to go through minus 3 as a y-intercept, and it's going to be slanting upwards like that. So I'm pretty sure of what I need to do. So basically, all I need to do before I start drawing is I need to find my x and y intercept of my hyperbola and my x-intercept of my straight line. So let's find my y-intercept first, because x equals 0 is so easy to do. So f of 0 is equal to 3 times 2 to the 0 minus 6. So it's 3 times 1, which is 3. 3 minus 6 is minus 3. Okay, so now I know that actually it doesn't go through the origin, and so I can actually find an x-intercept. So how do I find an x-intercept? I make y equal to 0. So 0 equals 3 times 2 to the x minus 6. If I move my 6 over, now don't forget I cannot multiply those two together. They're not the same base and they don't have the same exponent. So that 3 cannot possibly be combined with the base of 2. So never ever multiply them to get 6. So now I would divide by 3 on both sides, and then I'd get 2 to the power of x equals 2 to the power of 1. So x would have to be 1, which would make sense on my sketch. Okay, so finally, if I just find the x-intercept of my straight line, I should be ready to go. So 0 equals 3x minus 3. So 3 equals 3x, and x would be 1. So what do you know? It's going to go through the exact same dot. Okay, so now I'm ready for my axes and to accurately draw. Now, scale isn't really that important, but I must make it look kind of plausible. So I don't actually measure anything out. I'm going to draw my asymptote down here at y is equal to minus 6. My intercept is at negative 3. So halfway down, I'm just going to put negative 3. My other intercept of my exponential is at 1. Now there's nothing else on the x-axis, so I don't actually have to worry about any sort of scale on the x-axis, because there is nothing else on the x-axis. Because my straight line, I should actually label that. Was that f or g? Let's check. That was f. And g, what do you know? G is going straight through negative 3 and 1. So my straight line is not going to look like a very good straight line, because I don't have a ruler, but basically straight through those two would be G. And there we go. I've labeled my asymptotes, I've labeled my intercepts. Looks perfect. Okay, next question says, what is the average gradient of f, which is my hyperbola, on the interval 0 to 1? Now, first of all, what does on the interval 0 to 1 mean? That means from x is equal to 0 to x is equal to 1. Now, this is a fairly common question. We've done this before, and it says average gradient. And so average gradient, I know how to find average gradient. Average gradient is just pretend there's a straight line between those 2 points, y2 minus y1 over x2 minus x1. So I need to pretend that there's a straight line between those 2 points on the hyperbola and find the gradient. Now, it's only 1 mark. So if you were going to do quite a lot of work and find the 2 y values and do change in y over change in x, it's generally worth 3 marks. So why is this worth 1 mark? It's worth 1 mark because when I said to you pretend that there's a straight line between negative 3 and 1. Now y negative 3, sorry, I should say between, that jumped. Between 0 and 1, because this is when x is 0, pretend there's a straight line between those two and find that gradient. But hang on, there is a straight line between those two. That happens to be the straight line of my y is equal to 3x minus 3, I think it said. So I don't actually have to work out the average gradient. I know the average gradient. That average gradient is 3, because the gradient of that straight line has a value of 3. So I don't actually have to go work it out. I bet you if you actually went and worked it out, you would get 3 by doing change in y over change in x. But that's why it was only 1 mark, because you actually did have a straight line between those 2 points. Okay, this is the second time that this has come up. It is fairly common. For what values of x is the y value of the hyperbola times the y value of the straight line greater than or equal to 0? So you need to say y value of the hyperbola minus y value of the straight line is going to be positive. Now sorry, I said hyperbola, I meant exponential, my apologies. I think I've said that twice now. Anyway, so this is an exponential times the straight line. Now when would you ever multiply together to get a positive? Your signs would have to be the same. Either you'd have to have negative times a negative, or you'd have to have a positive times a positive. But I'm looking for when are my y values the same sign. So if I go up to my graph that I've drawn, if I start on the one side and I draw a vertical line, what are those two y values? Oh wait, those two y values are both negative. And if I carry on, y values are both negative, y values are both negative, both negative, both negative, both equal to 0. So at x is 1, both the y values are 0, which I am allowed because this said my y values must multiply together to give me 0 or greater than. So I'm allowed that. And if I carry on going after that, both these y values are positive. So in actual fact, these y values always have the same value. So, I'm sorry, not same value, the same sign. They're either both positive at the same time, or they're both negative at the same time, which means, well, any x value will work. So x is an element of real numbers is the solution to this question. If it was a little bit sneakier, and it had said when is it greater than and not equal to 0, then the answer would be x can be anything, except you would have to exclude when x is 1, because at 1 both the y values are 0. Now, it didn't say that in this case, and so I don't have to exclude anything, and my answer is x is an element of reals. Okay, question 4 done.